Oh wow, finally I can go back to campus and meet my friends. I should tell them about this right now.
Hey, Kai Yuan, you call us for what?
Yeah, what do you call us for?
You guys got read through the back to campus mail.
What mail?
You guys go check your Taylor's email and see.
Oh, yes, I found it. It's about returning to campus matters.
Oh, really? Then finally we can meet face to face on campus?
Yeah, we can, but in the mail it stated that all students will go back lah. They have to be divided into groups.
Is it like that? I wonder how many possible ways they can group us.
I think to solve this, we can actually apply permutation and combination that we learned in our discrete mathematics module.
Now let's talk about permutation. What is permutation? Permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangements matters. Common mathematical problems involve choosing only several items from a set of items within a certain order. Now let's take a look at the formula. In this case, M represents the total number of elements in a set, K represents the number of selected elements arranged in a specific order, and the exclamation mark represents the factorial. Now let's take a look at combination. What is combination? A combination is a mathematical technique that determines the number of possible arrangements in a collection of items when the order of the selection does not matter. In combinations, you can select the items in any order. Now, let's take a look at the formula. In this case, N represents the total number of elements in a set, K represents the number of selected objects, where the order of the objects is not important, and exclamation mark represents the factorial.
Moving on to the examples. The first example is lecturers need to choose 5 representatives among 77 students to attend a quiz. Inside the 5 representatives, there are 2 that need to be chosen to become the leader and the assistant leader. How many possible ways could the team be formed? In this question, we have 77 students in total, and in quiz team, it consists of 5 students. First, we need to choose 5 representatives from 77 students. In this case, we will be using combination since it does not require any arrangement. So, it will be 77C5. Now, in a team of 5, we need to choose 1 leader and 1 assistant leader. First of all, we know that choosing 2 students from 5 is 5C2. And as there are 2 different positions, so we need to times 2 factorial since both of the students can change their positions. So in this case, we get 5P2. The result will be 77C5 times 5P2. Lastly, there are a total of 395,156,300 ways the team can be formed.
Okay, so now we are in example 2. For the question of example 2 is possible combinations of each group if the group should be led by students of different ethnicities and consists of 7 members, including the leader. So how could we do this? So let's go to the next slide. And for this question, we only extract the students who are coming to face-to-face learning. So in the total of students who are coming to face-to-face learning are 49, and only 28 of them volunteer to be leaders. So let's see the statistic here. So for the Malaysian Malay, there's only 2 students, and there are also 2 students who volunteer to be leader. And Malaysian Chinese is 29, and 14 of them volunteer to be leader. And Malaysian Indian is 5, 4 of them chose to be a leader. And for the Malaysian others is 1, also 1 of them volunteer to be leader. And for the international students, there are a total of 12, and only 7 of them volunteer to be leader. So now we come to the next line, which has 6 boxes, box A, box B, C, D, E, and X. So for the box A is for the international student who volunteer to be leaders. so which we get 7 here. For the box B is Malaysian Chinese who volunteer to be leader, so which is 14 here, and C is for Malaysian Malay, which are 2 here who volunteer to be leader, and for the box D is Malaysian Indian, who only 4 of them volunteer to be leader, and box E here is Malaysian others and only 1, and for the box X is the students who didn't want to volunteer to be leader, which is 21 here total. So now let's see this. The lecturer will start by picking a leader from box A to E in alphabetical order and repeat. And after each leader is picked, the leader will pick 6 names strips from box X as their members. This process will repeat again until 7 groups are formed. So we also set the rules for this question, which are if the box X is empty, the leader must choose from box A to E in the alphabetical order. So if there is one box not enough to pick from, the leader must go to the next box, which is also in alphabetical order, and once the box is empty, the box will be removed. Okay, so now we come to the result part. So from the group 1 is an international student is picked from box A as a leader, and the leader will choose 6 members from box X. So here is the calculation. We get 7C1 times 21C6, which we get 379,848 ways. And for the group 2, a Malaysian Chinese is picked from box B as leader, and he or she will choose 6 members from box X. So we get 14C1 times 15C6, which we get 70,070 ways. And for the group 3, a Malaysian Malay is picked from box C as leader, and the leader will choose 6 members from box X. So we get 2C1 times 9C6, which you get 168 ways. So after all of this calculation, we left with the 2 statements here, which are box for the group 1. Box A is left with 6 names, and box X is left with 15 names. And group 2 is box B is left with 13 names, and X is left with 9 names. And group 3 is box C is left with 1 name, and box X is left with 3 names. Okay, so now we are in the group 4. So a Malaysian Indian is picked from box D as leader. The leader will choose 3 from box X and 3 from box A, because from the box X there are not enough members to choose from, so the leader must go to the next box, which is box A, in alphabetical order. So the calculation here is 4C1 times 3C3 times 6C3, which will get 100 ways. And for the group 5, Malaysian students whose ethnicity is others is picked as a leader, and he or she will choose 3 from box A and 3 from box B. So we get 1C1 times 3C3 times 13C3, which you get 286 ways. And group 6, because there are no more names is in box A, the leader will be picked from box B, who is a Malaysian Chinese who volunteered to be a leader. So we get 10C1 times 9C6, which you get 840 ways. So we also left with this statement here. Box D is left with 3 names, and X is empty. A is left with 3 names, and E for the group 5 here, the E and A is empty, and B is left with 10 names. And for the group 6 here, the box B is left with 3 names. So right now we are in the last group, group 7. Malaysian Malay is picked from box C as leader, and the leader will choose 3 from box B, 3 from box D. Okay, so now we will get this calculation here, 1C1 times 3C3 times 3C3, which we get the exact 1 way. Okay. So now the summary of all of this result is that all boxes are now empty. There will be 1 group led by an international students, 2 groups led by Malaysian Chinese students, 2 groups led by Malaysian Malay students, and 1 group led by Malaysian Indian students, and 1 group led by Malaysian students whose ethnicity falls under others.
Wow, so we can really apply permutation and combination in our daily life.
Yeah, we managed to use it to solve our real life problems.
Yeah, okay. Now that we learned something, let's just call this a day. Hope to see you guys on campus real soon. Bye-bye.
Bye.
Bye.